let's talk about the future of surgery. For those of you who listened to Fred Moll earlier on today, this is the immediate follow-up. So we've been talking a lot about hardware today. Let's think about what we can do with actual data and with software at a scale that I think has never been seen before. Surgery, if we're talking about the world of surgery at large, it's still very much an apprenticeship model, hasn't changed in hundreds and hundreds of years. As an apprenticeship model, it's very limited and it's very limiting. It's individual by nature. The impact is patient at a time. And leveraging data and leveraging artificial intelligence, I know there's a lot of buzz around it, we can actually do things very differently. And at Theator, what we've started to do is actually augment human surgeon performance by leveraging these capabilities. Now, in the future, the idea, like everyone's talking about robotic platforms, again, around the hardware. And we may have, in the next several years, robotic platforms that are able to pass a suture autonomously. But what happens when they pass a suture in the wrong plane? What happens when they nick a vessel? So these robotic platforms or hardware absent intelligence, and we're calling it surgical intelligence, is not really going to work. We need to augment the hardware capabilities and leverage intelligence, which I'll talk about, in order to make things really happen. And so this is the world that we're starting to build at Theator today. But what really makes a successful surgical procedure, or what makes a great surgeon? So several decades ago, Dr. Frank Spencer is known to have mentioned that it's really about situational awareness and decision making. That is really what differentiates, an amazing surgeon from one who's mediocre. Although there are no mediocre surgeons, obviously, they're all great. That is really what differentiates like someone who is the best from all the rest. But it's very hard to understand what best practices look like today, especially in a world where there's significant variability in the way that surgery is performed. There's variability within, between geographies. There's variability within a city. These are two examples just out of New York. And there's also variability within hospitals. And so this is really what we need to understand in order to then guide human surgeons and, in the future, robotic platforms. And so more and more hardware is only part of the solution. If we want to have impact not on a patient at a time, but we want to have impact at a larger scale, in order to understand best practices and disseminate them in ways that are very, very different from what's being done today, we need to think differently. And that's obviously where software comes into play, because software is limitless. And so this is everything that we're really leveraging at Theator and doing. So if you agree with me that data is powerful, then this is going to be mind-boggling. Most of the data today is lost. And if we have millions and millions of minimally invasive procedures that are done under visual guidance on a daily basis or on an annual basis across the world, most of them are not captured, they're not stored, and they're definitely not analyzed. And so ultimately, the status quo, or what we have today, is that we have really good understanding of outcomes, but we have very limited understanding of what leads us to them. So we're not talking about sci-fi, we're talking about like the world today. And so at Theator, what we're doing is starting to connect the dots. We're enabling routine capture of intraoperative performance and linking it to who the patient is and what the outcomes are in order to understand what these best practices look like. So data is powerful, gathering it is important, but we need to make it actionable because gathering hours and hours of intraoperative footage is meaningless. And so what we've done at Theator over the past several years is create a platform that automatically, and in hundreds of procedures across multiple specialties, identify key components or key moments within the surgical procedure. So these are steps, events, milestones, complexity analysis, ultimately decision-making points within a surgical procedure that make it or break it. It's all automated, and it's all done in real time. So this is an analysis my team did. We actually have more data than Netflix at this point in time. And all of this data is really structured. So it's all the meaningful aspects of intraoperative performance that can make a difference. All of them are identified. Now, technology for the sake of technology is really useless. We need to leverage it in order to have actual impact on patient care, provide value. At an individual patient level, obviously at a departmental level, and at a level of a healthcare system. And I'll give you a couple of examples. The first is a 1.5-year-old female patient that had to undergo surgery. During surgery, there was a moment in the procedure where something happened, the surgeon didn't notice it, software picked up on it. We're not providing real-time information just yet, but after surgery, immediately after surgery, the software provided that input, and they were able to take care of the patient in ways that were much better and avoid complications that otherwise would have gone missed until something really bad happened. This is a patient level, at a patient level. Another example, one of the best practices in hysterectomy is observing the ureter in order to avoid injury. At a department that had issues with injury to the ureter, we actually asked the department chair, so what % of the time do your surgeons take a deliberate view of the ureter in order to avoid it? The answer immediately is like close to 100. We have an algorithm that automatically identifies whether or not that happens. And when we took a look across the board over 4 months, we saw that that's really far from reality. And what you see here in the graph is actually the percentages of the % of time over 4 months that surgeons actually took a deliberate view of the ureter in hysterectomy, a commonly accepted best practice. Far from 100%, some don't take a look at it at all, others take a look at it some of the time. And the idea is that once we surface this information, this actually pushed them to a cultural shift where they started looking at things a lot closer. And so there was an increase in achieving the safety milestone. It was interesting, it was also coupled to more efficient procedures. Flow of surgery was done better. So quality was coupled to efficiency enhancement in the operating room, obviously very important. And when we take a look at 2 different hospitals, we see that some hospitals or departments are clustered. So everything is standardized. They take a look at the specific metric or best practice, and they do it routinely, each and every procedure very early on. And in others, this doesn't happen. So obviously, this connects with variability that I was talking about. And our approach to standardization is something that you can see here. And when we take a look at entire enterprise systems that have variability within them, but they have no idea why they're happening, this is where it really gets interesting. Don't have too much time to talk about this, but you can see here 2 different hospitals under the same logo, or 2 sites under the same logo, one with very high complication rates and another with low complication rates in the same procedure. Best practices are not disseminated, and they don't have a clue as to why things are happening. We're helping them here. In order for things to be meaningful, you have to have them in real time. So this is an example of a conference a few months ago where for the first time we demonstrated in real life a procedure being performed and transmitted to the stage. We demonstrated real-time identification of key components of the procedure. And this was cool. It's kind of sci-fi, but like the really important aspect of this is that if we are moving into a world where we will have real-time decision support, identification of key components of surgery has to be done pretty much like with very low latency and in real time. And so the idea is to change this apprenticeship model. Instead of having one surgeon behind my back telling me what to do in this case, to have the experience of thousands of surgeons in many procedures right in front of me, showing me the impact of the decisions that I make as a surgeon in a procedure. From a clinical perspective, financial perspective, et cetera. This is like decision support as we envision it in the future. And so hopefully I've been able to share with you what we do at an individual surgeon level, obviously the impact on patients, as well as the impact that data, structuring, artificial intelligence analysis can actually provide today to health systems. 20 seconds over. Thank you.